All right, so let's put that all together. We're being asked to graph the following transformed relation by first graphing y equals x squared and then applying the transformations in order. Order is just like we read left to right, that's the order we do it. So we're going to do this first, and then this, and then that. That's the order. So let's start by listing what these transformations actually are. My A is 1.5. And if I were to look at where that is on my number line, 1.5 is right here. It's between 1 and 2, so that means it's a stretch. Stretched by a factor of... So that's why I like thinking about it as a number line, because if you're just thinking about it as, well, decimal and a fraction is a compression, then that, like, this is a decimal, but it's still a stretch. Okay, my h is this value right here. There's a negative sign, so it's just this, just the 3. My h is 3. You can think of it as opposite of what it looks like. So h is 3, so that means I'm translating right 3 units. And my k is this value right here. So I'm going to translate negative means down. So there's a lot to remember here. So hopefully by the time you come to this point, you've had enough practice with just translations and just stretches and compressions before you actually get to putting it all together. With enough practice, you should be able to graph y equals x squared. That's what we're starting with. You should be able to graph it without looking at the table of values. So you should know -2, 4, 1, -1, 1, 0, 0, 1, 1, and 2, 4. You should be able to graph that without looking, with enough practice. So this is my y equals x squared. And again, I drew it on a slightly larger scale so that you can see. So I'm going to stretch by a factor of 1.5. That means I'm going to take each of my points. So that's what I'm doing first. Take each of my points, and I'm going to multiply the y value by 1.5. So here, the y value is 4. So I'm going to multiply it by 1.5. I have the other table of values here for you to see it. So now instead of, before it was 0.5, now it's 1.5. Okay, so 4 times 1.5 is 6. So instead of being at 4, this is actually going to be at 6. The x values don't change. The x values, you'll notice, it stays the same. It still has an x value of -2. It's just the y value that I've stretched. Okay, so here I have 1. When I multiply 1 by 1.5, I get 1.5. 0 times 1.5 is going to stay 0. And 1 times 1.5 is 1.5. 4 times 1.5 is 6 again. So you get the same numbers. Okay, so here I've only done the stretch. I haven't actually applied anything else. I've only applied the stretch. Next, I'm going to translate to the right 3 units and down 5 units. So like I said, by this point you should have enough practice with translations that you could do it in one step. So I'm going to take the blue graph, my transformed graph, and each of these key points, I'm going to go right 3, down 5. The only thing to be careful of is my scale. Notice how I'm skipping and going skip 1, skip 2, skip 3. So when you're translating it, you have to take that into account. So when I'm moving this one, if I'm counting 3 units, this is 1, this is 2, and this is 3. So I got to go skip 1 each time. And then 5 down, 1, 2, 3, 4, 5. So so it goes here. Okay, so sorry, ignore that. So be careful about that. So this is where my new point is. Then I'm going to do the same thing for this one. To the right 3, 1, 2, 3, and then down 5. 1, 2, 3, 4, 5. Do the same thing here. 1, 2, 3. 1, 2, 3, 4, 5. Okay. Then 1, 2, 3. 1, 2, 3, 4, 5. And see, I know I'm doing it right because this one ended up symmetrical to the other one. And 1, 2, 3. 1, 2, 3, 4, 5. This is symmetrical to that one. And that's my transformed graph. I've done all the transformations. So my equation is y equals 1.5 x minus 3 squared minus 5. And I can verify by looking at my vertex. Remember the vertex is h comma k. So in this case, my vertex is 3 comma negative 5. And if I look at what it ended up being, I have 3 and negative 5. So my vertex is in the right spot. I did the transformations correctly. You can check it like that.